What is having issue? What is having issue? Happens. I don't know why it's not working with you. So, so I said we have majorly four type of organization block. The startup hobbies, the thriving hobbies, periodic hobbies, and event driven. Okay. So under your periodic hobbies, you have your time of day interrupts, which I've given a sample that you can set maybe a maintenance time, maybe every 2 years, or don't say I expect to you. When somebody is dealing with you, does not want to pay you your money, just do the 1 month waiting. After 1 month, you cause a fault, and the person will have to come back and come and meet you. So it's just create more money. But that's by the way, that's not the major function. You can actually use it for other things. So between OB10 and OB17, these are blocks that does this, and there's your time delay interrupts. Okay, okay, no, that is the best thing. Sorry, your periodic on your interrupt will be your your cyclic interrupt. The cyclic interrupt are your OB30 to OB38. Okay, they function just like your normal OB1. They function just like your normal OB1. But what makes them different or unique is you can set the timing, the time they use, cycle time. Okay, let's take a look at let's take a look at our TIA portal and let's see. Okay, so you can see from here, if I right click on this image and just come down under interrupt. Okay, so this was the time of day interrupt we were talking about. So I can activate it. You can see the OB10, which was an example of interrupt OB10, and I can set the execution time either once, it will happen just once, or it will happen every maybe yearly or monthly. Then I can set the monthly time and date from here. Like I can say for 2025, I can put 2025 and put the date over here. Okay, I can just put the date over here and everything. So I'm not setting this. I'm just trying to show an example of time of day interrupt. Then you have time delay interrupt. Okay, time delay interrupt. Okay, so you can set these two will be 20 or be 21. These are time delay interrupts. Then we have the cyclic interrupt. That's what we're actually going to. You tend to use this more. Okay, especially when you want to do PID tuning. Okay, PID tuning, you want to ensure that your program is being scanned at a particular time every day, or not every day, at a particular interval. That's like call it cyclic interval. So for instance, you have your OB32. Your OB32, your OB32 um your OB32 has an interval of every 1 second, that is 1000 milliseconds. OB35 is 100 every 100 milliseconds. So I tend to use this for instance, like I said, for process control or very critical programs. For instance, I want to do OB programming, Modbus programming. I'm pulling data from different locations. So I want to ensure that I'm getting that signals right. Okay, so you tend to use your OB35, your OB35 for this. Okay, you tend to use your OB35 for it. So every 100 milliseconds. So like I said, let me just use it for example. Um, Using an example using that they are your side sheets. Okay, so if you have a side sheet, how the OB runs. Ryan, Alright, so I was explaining, I was about to explain something. So if this block is your OB1 and this is your OB35 or any OB you have set, what the PLC does is when it's scanning, it's always scanning this one continuously, right? So it's always scanning this one continuously. But if this OB35 is a 100 milliseconds, is a 100 milliseconds OB, what it does is every 100 milliseconds it will run here, scan it, finish, then go back to OB1. So like I said, it's just like a cycle. You always want to quickly attend and come back to its OB1. So quickly go, then come back, go, then come back, go, then come back. Okay? So if it's every 1 second, that means it's scanning this one continuously. I think OB, you can see on the screen that OB, I think I'm saying that will be 30, 32 is every 1 second. So this is actually will be 32. Every 1 second it runs out and scan this, then come back to your. So if you look at the priority number is quite higher than your normal will be one. Okay, so the higher the number, the higher the priority actually. So OB35 has more priority than OB32. So if 35 and 32 is supposed to come up at the same time, it will actually go to 35 first before going to 32. So, yes, because of the priority number. So you always attend to that. You always attend to that first. Yes. So you can't change the priority of this guy, but that's a fixed priority. But when it comes to your 1200, you actually create an OB and set the priority and the scan time. I think so, and the scan time. Let's get back to our screen. So, yeah. Okay. So we also have hardware interrupts. We call them interrupt OBs. Okay, hardware interrupt or event driven. Okay, they call them they are classified under interrupt and event driven because they happen because something has happened. For instance, before the 247 is an hardware interrupt. Why? Because if there's an issue with your hardware, that is a PLC problem, a system fault, okay, all those kind of error, okay, it brings up this OB. So we call them hardware interrupt OB. Let's look at the sample of it. So if you look at our screen, CI portal screen, okay, you will see that under hardware interrupt, you have OB40. They didn't describe it here. I don't know if you know that. So this is also another thing about CPUs. Some CPUs have some hardware, I mean some OBs that you can actually correct. For instance, let's add a new block. Let's see if we can add a new block. Add a new block. Okay. So if you go under organization block, you can see that you can add any type of organization block you want. But I want an hardware interrupt. The only hardware interrupt that this guy understands is this one, hardware interrupt 0. But there are more than this hardware interrupts. Time of day interrupt too is only 20 and 21. Okay. Startup, it has understand only OB100. So there are different type of startup OBs. There is your hot startup, warm restart, and warm restart, warm reset. I think you get. There are about four types of startup. So how do you want it to start up? Say hot restart, complete restart, or the like. So there are um, different types. There's also fault interrupt, like I discussed. There is side circle fault, IO fault, means there is a missing input or output in your diagram. What should happen? There is a rack fault, there is common fault, there is programming error, there is a program error in your system. What should happen? There is a module error too. What should happen when any of these issues is actually coming up? One important thing to why understanding how OP work Let you know how to tackle issues. Okay, there are some errors that will occur that if these OBs are inside, it will not happen. It will not totally shut down the system or give you a system fault. That's why sometimes when you go to France, you can be seeing a system fault, but the system is still running because there are OBs that are already handling those faults. So a very poor way of programming some system is, for instance, you have a bus cable or you have an Ethernet cable connected to a drive or another system. If you unplug that cable, all the machine will stop. That is not a safe way of actually writing or programming a system. It should not stop all your system. It should be able to just give you an alarm unless it is a critical input. Okay, when the critical that thing can say to stop the system. For instance, you have a line where you have your depalettizer, you have your filler, all those systems, your pasteurizer and all. For instance, your conveyor is not working, then does that mean that your filling is not work? What about the bottle that have passed the bottle washer, for instance? No, you have to wash the bottle before you fill it. So just imagine that your filling is working, but because your bottle washer is not working, you will not be able to do your filling because of an hardware interrupt. Okay, instead of that, you put that hardware interrupt OB into your system that even if there's an issue, it will keep running because we can actually manually load the bottles so that it will fill while they are trying to resolve the bottle washer or the cleaner or whatever or the pasteurizer, whatever issue is wrong with the machine. So these are the importance of OBs. Okay, but there's a time that your program that you will just open the OBs and you will not see anything inside. Why? There are capturing OBs. So it ensures that it does not it ensures that it does not stop your system. That is the main thing. To ensure that your system at no point stops. You can just give it the alarm. And based on your program, some part of it, some part of the system, some part of the system might not work. Some part of the system might not work. So these are the importance of your OBs. You have your IO error OB, like I said. You have your profitable error OBs. You have your programming error OPs. What can cause programming error? For instance, you can have an overflow. For instance, you have a counter, okay, linked to the number that the memory, basically the memory disk can count. They are counting more than I think 3 to 76 things, something around that, or I think minus that, about to read negative. Okay, you can cause an overflow in the system, or you are multiplying the number is too big for the memory to actually contain, it gives you a programming error. But if you have that block, like I said, it will not capture that error and ensure that it will not stop the PLC. So it cannot be giving you the warning, okay, but it's still there. And you exactly cause this kind of things minor error and major errors. So it's not like you are configuring it as minor error. So you can configure some errors that okay, this error of 4, it should not stop the system. Minor errors cannot stop the system. The system will keep on running. But major errors will actually stop the system from actually running. So you must be able to differentiate between those two. Okay, let's go back to our slide. So see from our slide, you can see they explained each of them. Let us go through it to get a better understanding. The startup program is carried out before the cycling program. Okay, what is cycling program? Okay, one. So the startup will always come up before that. After a power recovery or a change of operating mode. So you change the mode of your PLC from run to maybe from run to start. If you start up, this time that you need to actually make is actually carrying out what is in the startup what is in the startup orbit. They will talk about the cycling program, that is the OB1. Okay, this is program that is to be continuously executed. Okay, that is to be continuously executed and installed in OB1. Okay, so the scan time and the response time of the system is a result of this operation. So the response time is the total of the executing time of the CPU operating system and the time it takes to execute all of the user programs. When you talk about response time, the difference between cycle time and response time. Okay, your scan time or what you call your cycle time is the time taken for your PLC to actually what read your input, read your input states. Okay, read your input states, compare it to a program that is programming it, then giving out an output. So that's what you call the cycle time. The time taken read input, give compare it to your given program, then give you an output. That's your cycle time. Your response time is now the time it actually takes depending on your program. That's why it's not advisable to overload your OP1 with program. But the more the program, the lesser the scan time. So every PLC has a designated scan time. For instance, let's go back to our time portal. So we come back to our time portal here. If you go under general, you can see that this is the scan time here. Okay, so means this CPU can actually do 0.05 milliseconds per 1000 instructions. So for if you take it 0.05 milliseconds for 1000 instructions. So just imagine you now have 5,000, 10,000 instructions inside that particular PLC. It takes more time. Let me add a new CPU so we just tend to see the difference. Compare this to a 1215C. So you can see this one scan time is quite lower. It should be somewhere here. They didn't state it. They used to state it. Thank you for your teeth. Let me just add it first. Add it to share that information. It should. Yes. You can. I thought I said that. Okay, it should be stated. I don't know why it's not here. It used to be scan time. It's not here. Where do I get it from? I think it's from. I get it from. Let me check on that. There's a way to also check it when you go online with it. You can just take these online tools and it will actually show you the current scan time of the system. Then you find out that the more the DB you have, the more the FC you have, the more time it will take for you to actually scan through every of the systems that you have. Okay, so back to our manual. So we said our periodic program execution. This is you can interrupt the cyclic program at fixed intervals with your be 30 to 37. So you can execute a set timing code. Okay, so it allows you to run a code every 100 milliseconds. You can even run a code, for instance, we want to talk about IoT. You want to be able to pull data every second. You just write the program there and you use it to pull your data. One important thing of your OB 30 to 35 is that you can use them to shorten the instructions like the scan time of the PLC. So instead, if you put all the program in OB1, it will scan everything, even if it's not working. For instance, maybe you have 20 step program. If you have to do 20 things, 20 different steps, and one step can have like a lot of programs. So instead of having all of them inside, it will keep scanning all of them. It will scan the input of this 20 steps, and it's still on step 2, and they are telling you to scan step 20. So you are stressing it out. So that's the importance of having FDs and FC. You can use to segment your program. So when it just tries to enter and see that it's not yet the step, you are on step 2. So it will just scan. So instead of doing step 1, step 2, down to 20, it will come. You have a condition that once step 1 is done, start step 2. Once step 2 is done, start step 3. So if it comes there first and sees this that this is examining space is not yet true, it will just keep that empty. Thereby, you are actually saving memory space inside the CPU. So instead of scanning all the 20, then only doing one, it will just come and see we are on one. So each time it just go to one. When you are done with one, it goes to two. or it's count one and two. That is what you want to do. Count one and two, count one and two, count one and three, count one and three. It makes your process faster and reduce the stress on your CPU. Then you have your event driven, you can read those up. So these are your startup cookies work. You can also check this out yourself. Okay, it carries out your complete restart. Okay, when you power on, it deletes the process, no retentive memory. Those are the first thing it does. Then execute OB100. Instead of OB100 is the startup OBs. Then it enables the output, okay, your PIQ output, okay, before it now starts doing your what, everything you have in your OP1. So it reads your input, compares to the program you wrote in your OP1, give your output, then start all over again. This is what you call your cycle time, okay, your scan time. Okay, it does this at interval every time. But like I said, you can have it in your OP1, a short program in your OP1 to enable some output at first, beginning of the process, before it start reading your normal OP1. Same thing goes for restart manually. It reads OP100, the process, everything inside, monitor the start. If it's not up to, if it's not, it has not gotten to the desired point, what it does is it stops your system. So you can have some condition that if all these are not met, okay, your PLC should stop, it should not run. Okay, that's why you call them startup OPs. And there are three types of startup OPs. I think I mentioned that. I said that particular CPU just has only one. So depending on the CPU, that's why you can know the type of startup it has. There is complete restart, one restart, and full restart. Any CPU that have these three is very, very strong CPU. But let's say 3174 for your S7400. Your phone S7300 has complete restart. Complete restart is the general one that all CPU has. There's one restart. So what's the difference between these restarts? I know you really practical. Let me just keep them in. Okay, for a complete restart, this is a type of startup that deletes the process image. So when we talk about PII, process image input. PIQ is process image output. So when we talk about PII and PIQ, we are talking about all the input and output. So we call them PII. So 0.1, 0.2, 0.3 down to 224.0. So I'm talking about all the inputs. So you call them process image input and PIP process image output. What it does is delete them and all non-retentive memory, both your timer, your counters. Okay? Then your retentive bit and memory and counter as well as data flow current value are retained only with battery backup. With the S7300 even without battery backup, if and if one is used and the CPU retentive behavior has been parameterized. So there's way to actually remember what you have done on that particular CPU. Let me explain a bit further. For your S7300 without battery backup, I think the phone that we have here without battery backup is making use of what you call an EEPROM memory card. Okay, that's an EEPROM memory card. This one too, this one too. I think three of them are the same. There are some that have one small battery, one small tiny battery that you can plug in. So if those battery is bad, you can't retain it. So this does not retain the input state or output state, okay, or the counter state. It only retains your bit memory, timers and counters only if you have configured it from your hardware configuration. Okay, if it has been parameterized. How can you do that? Let's go back to our CI portal again. Okay, let's go back to our CI portal and see. Let me use this CPU. This is what we use for the training. I go down to detentive memory. Where's detentive memory? Start up. You can see this is your one way start. Okay, that's your one way start. This is your startup mode. Your one way start. You can configure how many seconds. Okay, you can see sometimes it's slower before it will come to wrong mode, okay, you can actually configure your time. Specify a maximum time period during which the iron must start up. So if during this time it does not work, you know that there's a problem and it takes the CPU back to stop mode. So I'm going to show you where you enable your symbol retentive somewhere there. Uh-huh. I'm on the wrong CPU. I was looking for it on that shortcut. So retentive memory, yes. So this, if you want to remember your DP numbers or your counters, you tend to put it here. So I'm saying number of memory bytes starting from byte 0, I say 16. That means from NB, I explained bit byte for you yesterday. Byte is what? 8 bits, right? So they're saying what byte number. So I'm saying I want to retain from memory byte 0 down to memory byte 16. So means they are retained even if I turn off and I have added it parameterized it, it's going to remember that. Timer, what value do I want it to remember? Here it says 0, means I don't want it to remember any of the timer value. Counter is up to counter 8. Okay? Counter. So these retentive values are parameterized that even when the at startup, it remembers it and brings it back. Unless you carry out a memory reset. Okay, unless you carry out a memory reset. So the only way you can clear those retentive memory is when you come here and do this reset. One, two, um, two, so like this, it clears whatever is that retentive memory. So that's why most times you see people that just say ah, there's an issue, let's just restart the system and they just go power up and power up and it's not going to work out until you reset. People think sometimes people think when you press that reset, it clears the program from the PLC. No, it clears the retentive memory area of the CPU. Talking to talking to Alright, let's go on now. Don't worry. I just need us to have that on our head. So let's just go back to our manual. So this shows how you interrupt your OBs and all. I think I even explained that already. I just check, I always check so you can see how the OB1 is repeated, then it goes to OB10, time of day interrupt. Then every 9:30 p.m. or a.m. it goes to that block. Then after it does, and it quickly comes back to your OB1. And if there is anything like OB20 or OB82 or OB35, you just keep interrupting it based on their priority. So if all of them are supposed to come up at the same time, it picks the one with the highest priority. You can see error handling as highest priority. Means if there's an error, suppose law, it will just stop everything. Okay, so try to resolve the error from the program. There's no program that can just stop there. It goes to hardware interrupt, cyclic interrupt. The one with the least priority is the OB1. Oh, forgive me. They will leave their wife and go and answer sidekick. Sidekick will say, I need 1 million. They'll give his wife. Wife is asking for the same money. They won't give her, or they'll go and give that one outside. Yeah, exactly. So just I don't have, I don't have. Amen. All right. I won't want to what I was looking for. Basically, hardware interrupt is caused by an overflow, especially in analog. When there's an overflow of your signal, you're supposed to be getting between 0 to 27648. You're now getting higher than it, or there's a wire break in the transmitter, level transmitter, flow transmitter, whatsoever gives you an hardware error, or there's an unplugged module or a damaged module. It can tend to give you an error. you are not expecting. You know, okay, just you know, tell me to Okay, subroutines. Let me hear myself. Oh, it's better now. So when we talk about subroutines are more like baby baby I won't go into the word. There are ways you can section your program actually, ways you can help you. And I'm trying to avoid using the word organize because we already have organization block. Okay, they help you organize your program into groups. Okay, into groups. For instance, let's say this is our OB1. So instead of just having programs written all over the block, I can just have a call and I call this in an FC. So this can have the program for pump control. I want to control pumps. Okay, I can have another program for my maybe I have different generator. I can call this genset one. Okay, then I can call this under genset two. So I can even call this one without this. Okay, so there are different ways you can actually call either your function call or your function block. Okay, if I'm putting a condition before calling my FB or FC, it's called a conditional call. Okay, a conditional call means something must have been done. For instance, like I say, I must have pressed my start button or toggle my start switch first before whatever is in this process can run. In this case, call it a conditional call. Why this is called a non-conditional call? Okay, means the PLC will always scan this. So when you are doing your scan time, as long as you have not pressed toggle this switch, the PLC will not scan what is inside this block. That is, these are the importance of putting them in blocks. It just starts and scan. Is the switch on? No. Move to the next one. Oh, unconditional code. Then to go in and answer the first son of its original wife. You don't get it, forget about it. Okay? So I mean it will scan the first or second block inside your OB1 since there is a continuous block. So for Genset 2 is conditional. Okay, you must have done something first, or Genset 1 must have gotten to a particular speed before you bring in Genset 2. Okay, so we call this conditional and unconditional block. So inside this FC, let's call it 2, I might have a program maybe a timer program or whatever, actually running inside, this block. So whenever the PLC comes, it tries to scan, if it's true, it wants to come out of it, goes to the next one, come out of it, goes to the next one, come out of it.
If I want to add,
Okay?
like this FC2, it's a program that the PLCs can like
Yes.
like if you want to like you are having a lot of things and then you just want to like summarize them,
Okay.
put them in a shorter way. But is the program written for and named?
Yes, you have to create the FC or the FB first.
Okay.
Okay, you have to create the FC of the FB first before you can call it. You can't just call it. You create it first, write your program, all what you want it to run before you call it into your OB1. Okay, before you call it into your OB1. You can also call your blocks into your OB35. Ali used to have type now. Your You can have baby mama. So your OB35 and others that are like baby mama can still have children for you, or if you are hiding them. Okay, you are hiding them. Alright, so that's just to explain that you can have also call FC and FB in OB35. So you can have OB35 and also call this same FC2 into it. Yes, you can call it as many times. Then that's when I talk about multi-instance call. We'll talk about that. But first of all, I want us to we'll use each of these first, then come and use DB, and then we'll now come and talk about multi-instance capability. Multi-instance capability is writing a code that you can use as many times as you want and without causing any conflict. You can to make it makes it much more faster for the PLC to reason. Instead of writing the same program 20 times, you write it one time and it just keeps scanning it and replacing it to the right data block. So what about your function block? Your function block does exactly what your FC does, which is to help you organize and arrange your program well. But the only difference is that your FBs would always need a DB. Your FB always need a DB, while your FC does not always need a DB. So your FB is DP dependent, while your FC are not DB dependent. Okay, you can use DB in them, fine. You can use memory bits, you can use I or PII or PIQ in them, they work fine. But for FB, once you call an FB inside an OB, it will start requesting for you to attach a DB. Why is that? Because the FB is a much more special guy, because you can store its own data in a memory bit so that it can remember, and is meant for only that FB. So it always has a memory meant for it alone. Nobody can know what is inside the memory. Nobody else can actually have access or write into that. You can actually write into it, yes, can write into it, but it's still dependent on the parent of it. The parent of it is the FB, yes. So you can now use the data block from here, dbx one.db dbd2. Okay, you can call it here and make use of it for something else. Okay, so it's not limited to it, but it's majorly for it. If I want to access memory of this FB, I have to use this DB and refer it directly inside an OB, or I refer it into an FC. Okay, I refer it into an OB, or I refer it into an FC. That makes it easier, and make it easier. So the major difference between them is the DBs, is the DB, that's what makes them different. Apart from that, it stands out actually. The other difference, if I remember, I will keep it in. Then the last guy we have on this block is our data block. Okay, the last guy we have is our data block. What is data block? Okay, data block is used for storing data, obviously. Okay, so of course it's obviously used to store data. It's used to store data, obviously. I say that right. Okay. So let me open the slide for those that are viewing online to also be able to follow. So I can also see from here. So data storage in data block. So storage area for data, as you can see on the screen, there are different storage area. We are used to memory bits. I think you say you can use memory bits, right? Can you? Yes. You can have M0.0, or you can have MB1, or you can have MW2 down to as many as you want, or you can have MD24 or whatsoever that you have. All these are memory bits on the CPU itself. On the CPU memory is different from a special place. Okay, so your data block is just like a special drawer where you actually store data specifically for basically for data purposes. So what is the difference between these data blocks? What is going to say M0.0, MB1, MW1? What is the difference? Somebody help us out. Right. Let me give us a better explanation. So yesterday we talked about bits, bytes, bits, bytes, bits, byte, word, double word, right? Yes. So we said that a bit is either a one or a what?
Zero.
Or a zero. Alright? Then we say our byte is made up of what?
8.
8 bits. Okay? So I said for bits you have just one box, which can either be one or zero. Right? So for a byte is made up of 8 bits. So maybe something like this. 1, 2, 3, 4, 5, 6, 5, 4, 9. It's even too big. I'm not going to explain the part, but I'm going to from here. One, two, three, four, five, 7. Okay. So if you are arranging this in the data block, this is what 0, 1, 2, 3, 4, 5, 6, 7. Right? So this is a what? Byte. This will be 1 byte. The other byte will be what? 1, 2, 3, 4, 5, 6, 7. That is 0, 1, 2, 3, 4, 5, 6. So I can call this memory byte 0, right? Because this is the first byte. The next byte is going to be what? Memory byte 1. Are we together? So it is these 2 bytes that now make up what you call what? A word. It's going to be what? Memory word. Memory word what? 0. Okay? MB0 and MB1 is memory word 0. MB1, let's arrange it like this one. This is very crucial for us to understand. MB0, MB1, MB2, MB3, MB4. Let me stop at MB4. Okay? MB0 and MB1 is what? Memory word 0. MB1 and MB2 is what? Memory word 1. MB3 and MB2 is what? MB4 and MB3 is what? Memory word 10. All together. So this is why it is advisable when we start using memory bits that you should not use memory word 1 and use memory word 0. Why? Because both of them are sharing memory word 1. What does that mean? Means if I want to do something like this, I bring this together. This is memory word 0, right? So if I want to use memory word 1, that means I have to use what? Memory byte 1 and memory byte 2. Two of them are sharing MB1. So there's going to be a conflict of data. So if you push some data into memory byte 1 and memory byte 0, you already memory byte 1, memory word 1, and you have already used memory word 0. Wahala ti ṣẹlẹ̀. Okay, so it's always advisable that when you are dealing with word, you skip one. So that is, if I'm using memory word 0, I should not use memory word 1. I should go to word memory word 2. If I use memory word 2, I should not use 3. I should go to word 4. By then, we are using these two. Then the next one is 2 and 3. Then 4 and 5. Then 6 and 7, or and so on and so forth. And you keep going like that. Okay, you keep going like that. Same thing goes for your word. Okay, for your word, this and this, so your double word, this is memory double word 0. This and this is memory double word 1. This and memory word 4 is memory double word 2. Are we together? All right, so it's advisable to skip what 1 if you are using memory word MD0, because this has occupied 4 bytes already. This guy, he has occupied 3, I mean, yes, 4 bytes. That is 1, 2, 3, 4. Yes, memory word. Yes, but not using memory word. This thing, use memory word 2. So this guy has occupied
from 0.
Yes, 2, yes, 1, 2, 3, 4. Yes, to occupy 4. So double word, 2 words now. It occupy.
2 words is 32 bits.
Yes,
So
that is
if you take 1, 2, 3, 4, yes.
2 words, 32 bit, right?
Yes.
Is this thing I did that's obviously? Yes, they occupy this 0 and 2 up to 2. So it has occupied the memory double word. So it's advisable to use double word 2 upward. See, the rule of facts, the rule of thumb, they call it, or which grammar we are using. Anytime we are dealing with memory word, I make a rule that I start my memory double word from like 30 upward. Because from bit level, I may be using M0.1, M0.2. Mind you, if you are using M0.1, M0.2, you cannot use MW0. Why? Because you have used the word M0.0, you have put a value inside it. You just keep noticing in your program that it's always scattering and everything. Okay, so you have to ensure that you are arranging your data well. So give them space. You can say memory word, okay, I will start my memory word at 12. So you know you are giving M0.0 to M to like M24.0, even more for you said. Okay, but you are giving yourself space, so you have liberty to use as much as you want, but you ensure you are separating them. Anytime I want to do double word, I start from like 60, MD60, MD50, MD60, so that I'm sure that I've not used it for bit or byte or word. So I give it space. So with this is a headache on its own for me, or for any programmer. It's like, what's all this now? And again, you cannot determine the data type. Okay, you cannot determine the data type. If you want to do real, you might not understand that now. Okay, if you want to do real, integers, and others. Okay, that is where data block now comes in. Data block saves you from all this wahala of clashing memories together. Okay, and gives you the freedom to be able to define what you want to use anyhow you want. Okay, you can now define it as array or define as structure. We'll be looking at the different type of data types. Okay, so you are now at liberty to choose what you want to choose. So that leads us to the type of data type. There are 2 types of data type of data block. What do we call this again? Sorry. We have instant DB, instance DB, and global DB. I think this is what I call them. Instant DB, global DB. I think there's another word. They have 2 names for them. Let me just pick through. Yes, global and instance. Yes, global and instance. Okay. So the normally you can call the instance local. So that also work. So if you look at the diagram on your screen, you can see this thing. That shows you how your function block is. You can see a global DB is accessible to all blocks. So both your function block, both your FCs and your FB can have access to global DB. Okay, but for your instance DB, it's only an FB that can have access to an instant DB. That's why I was saying that is the importance or one important value of function block. Okay, your function block has its own block dedicated to itself. That's why they call it instance DB. So instance DB is always declared when you are creating an FB. So you can create an FB and automatically create an instance DB with it. We'll be seeing all this when we start doing the practical. I just want to cover up a lot of the theory today. This first hour before we go, we have like 2 minutes to talk. So we go on a 30 minute or 20-minute break. Okay, so your instance DB is meant for your FBs, global DB for anybody. So unlike your OBs that they are special DBs, that they are special OB numbers, this one does not have any special OB numbers. You can use any OB number that you like and it would to do the work for you. Okay, so it's not that DB1 is only for FB or no. You can create as much as you want, but it is how you are defining them that will actually determine where you are going to actually make use of them. So we're going to talk about data type, so I won't want to rush us. So once we will just go for maybe a 10 or 15-minute break to rest our head a bit. If too much information is entering there, we tend to be choked up with information. So when we come back, we'll talk about data types. Okay, we'll talk about data types and the swing into action on full practical. I'll give us the project up here. I'll do full practical and we're good. But so far, any questions? Grab 1 minute, I can answer any of our questions. Any question? No. I may just take question when we come back. All right, thank you very much. Stopping the recording here and it's going. We will continue in 15 to 20 minutes.